recording. And I will bring up, how do we want to start? I'll tell you what we'll do to begin with. We'll show you the one thing I mentioned on the call quite a lot is HTML page caching. And the performance difference in this is ridiculous to the point that if you're ever building your own piece of software, you should just try and do this, because Rails is best going to handle, I think you can get it up to 1,000 to 1,500 requests per second. You need a really beefy server to get it to that point. But Nginx will serve serve tens of thousands of requests per second on a Raspberry Pi or something. It's just crazy. It's really, really efficient. So if you can get HTML page caching working, it works really well. So I'm going to use my own site as an example of this, and then we'll look at GitLab for the other stuff, because we might be able to do this at GitLab. There are some tricks to using it, but obviously the disk side of it can be a bit problematic. So let's have a look at this is very tall. Hold on. Oh god, there we go. Right, is that actually 1080p now? Probably. Nice. Okay, so here's my rubbish review of an iPad. Looking at the performance thing in the browser is very useful, actually. So you can ignore most of the other bits. What we're looking at is the initial request speed. And on this article, it's 92 milliseconds, which is just under that 100 milliseconds, and not the reason that I set the 100 millisecond target for my performance thing, because I knew I could get under it. It's really interesting when you look into the speed of where the actual response time is. The actual page rendering time for this page is 31 milliseconds to actually return it to the browser. That's your best case scenario. You're probably not going to get much faster than that, because you've got the transfer speed of it, essentially. The other parts of it are tied into TLS and just connecting to the server in the first place. And in that regard, this is pretty much your best case scenario. And the reason why it works is because this is just a HTML page that's being rendered to my server. It's served off of disk for every page request. And it will really consistently run. It's going to fall over now as soon as I do. But you can sit here refreshing it, and it's just like, you can even shift refresh. I'm just going to move this. How do I move the zoom bar? Anyway, you can just sit here like mashing it, and it's, oh no, it went over 100 milliseconds. And it'll be pretty much consistent. And it's just because it's a HTML file. And the reason why that works is because, how do you turn off JavaScript on this? Do you remember how you turn off JavaScript on it? I don't. I can't bother going through the settings. Basically, the menu bar up here is put in with JavaScript. You might even be able to see it very briefly flicker. And that's a trick I use a lot. It's kind of going back to an older form of web programming, I guess. You don't get as much anymore, which is progressive enhancement. Rather than having a single page application, you have a page that works by default without JavaScript, and then the JavaScript just makes it better. That's a really nice goal. In fact, that is kind of how we do a lot of stuff at GitLab. We have a lot of pages that are fetching stuff from the server side, they're rendering on the server side, and then they're regenerating it and adding stuff to it on the browser. And that's something that makes a lot of sense. It's also better for accessibility. I know screen readers are getting better. I mean, GitLab's difficult in terms of accessibility because it's quite complicated. It's got a lot going on. It's going to be hard to get accessibility working for screen readers and stuff, but even non-screen readers, it's important, and speed is important on the server side to get it responding as fast as possible for the front end to then load. The faster you get that first response, the faster the front end loads. It's just generally beneficial. So I use tricks like that quite a lot. So I'll stop sharing that one, and we will look. If anyone's a really good Vim user, by the way, please don't mock me, because I'm still really, I've used Vim for years and I don't even know half the key bindings. I use arrow keys to like wander around stuff. I have no idea what I'm doing. So here is a terminal. And we will look at, let's look at, I need to find it first, that's a good point. Oh, what was it called? there's something I added recently. We added recently. We've added a couple of caches that are kind of like keyless caches where they just rely on the timeout. They don't expire based on anything else. They're just to cut quite heavy load, and they are purposefully stale, essentially. So I'm just going to try and find that. So what was it called? Oh, that was a mistake. That is not a long enough storage alert limit, I think it was. Oh, so yeah, so I put a couple of screenshots of this in the presentation, where this was kind of problematic. We found that this payload, where you're checking the storage size service for a namespace on GitLab, so this is checking whether a namespace has exceeded their storage quota, and it does this on every page load inside that namespace, and it was quite expensive. I mean, it's not expensive, but it was 70 milliseconds, and if you think, well, we're trying to get to a 100 millisecond page load, that's a big budget. A part of your budget has been spent on a storage alert banner. But does it really make a difference if that banner is displayed up to 1 minute past the storage having been exceeded? Because the storage limit's probably been exceeded in a Git push. There's a delay there anyway before it ever gets to GitLab, because we have to process all the commits and stuff like that. And the chances are as well that you, at worst case, it'll be a minute late. Chances are it'll be 5 seconds late, you know, very, very minor. And you're cutting a really large amount of traffic from the database. And so in this regard, this payload bit there is what we needed to limit. And you could add caching in the helper, but where Rails is very useful is where it does that template tree digest stuff in the template. If you change stuff in the template, the cache keys will rotate, which means that you don't have to worry about having stale caches when you push changes to your application. As far as I know, it doesn't do that in helpers. So when you put a cache in a helper, you kind of got to just keep that in mind, that that might not happen. They could tweak it. They may even have done it since they originally implemented it. I haven't actually checked lately. But it's kind of effective. So in this regard, we've got, I think, a helper method in here, which I mentioned on the slides, which is this one around, that's used to count the number of storage alert limit things to get around some awkwardness in needing that query data. Let's see if I can actually find. So here's where the cache is implemented on this. So you can see it's just got an expiry time of 1 minute, and then it's scoped to the namespace and the number of those hidden storage alert banners. And that feels like a bit of an odd cache. It feels like it's not caching a huge amount of stuff, but it's actually, in this regard, the template is not very expensive. None of this takes very long to render. Most of it just helper calls, putting strings. There's no loops in it. So the template in this regard isn't expensive. The query is what was expensive here, the payload request. I came across something interesting in this, which I never actually knew. And that if the original version of this template had like an early return if the payload was empty. So instead of this unless payload empty there, it had return if payload empty. And that just totally breaks the cache. It actually exits out of the block for the cache call and doesn't write a cache value, so it doesn't write a nil cache value. And it will cause it to just be re-executed every time. So it actually has no effect whatsoever and kind of breaks it. So in that regard, don't have breaks and returns inside the cache block. You want to use something like a unless, and it looks a little bit lamer, but it actually works, which is kind of what we're going for. So the actual performance benefit of that isn't necessarily super noticeable, because what it's doing is quite subtle. You're cutting a 70 millisecond query from a good portion of page loads, but that sort of thing, you're probably not expecting it to show up in the stats because we have such a high level of traffic. 70 milliseconds is just a margin of error. To see something dramatic on your Grafana charts, it needs to be a dramatic cache that just caches an entire thing or cuts seconds off of some time. So we can take a look at some of that as well. I don't know if anyone's got any specific questions they want to look at or any areas. If anyone has got anything, I'm just going to drop out of the screen share for a minute, mostly because I can't figure out where the chat panel went. And I'll find cool, right. Does anyone have any particular pain points in the GitLab applications that they find are slow? Is there, like, I'm taking any suggestions here. I have some personal ones. I've got them sort of ready. I've even got merge requests I made earlier in proper Blue Peter fashion for anyone in the UK. But I'm happy to look at other ones first if there are any. I'm glad you said that. That's the one I prepared earlier. I have fixed the pipeline tab on MRs. I say fixed. I have cached the pipeline tab on MRs and glossed over the massive amount of JSON it renders. It is huge. Let me find the merge request. We'll just look at this straight in the GitLab UI. Right, let's have a look. Okay. So, yes, this actually, you can even see this as an example in its own merge request, which I'm very happy about. The pipelines tab, the more pipelines you have, the slower it gets, and it is quite painful. I mean, that was a good some seconds. I didn't actually, and the thing is, because it's not cached, you can just do it again. Let's have a, watch this. It does cache it for the polling. It actually uses HTTP caching. So you can see it reloaded it there fine. And I think that's because it's cached in my browser. It should be, yeah, if we go force refresh. So that's a good example of a use case for HTTP caching. It was HTTP caching, but the actual response speed of that is just quite, there were 5 seconds, which is not super great. That's at risk of hitting timeouts. It gets worse. I've had one with up to about 25, 30 pipelines, and it just does get worse. This is a great use case for that multi-fragment caching that I talked about before. And it's where I thought, when I first came across this, I was like, yes, I'll just go and add multi-fetch fragments, store caching to that. It'll be solved. Everyone will think I'm brilliant. And then I went and looked at it, and it's actually a problem in grape entity again. So this is all serialized JSON, and it's done in something in our serializers folder, which is where we're using grape entities to serialize JSON, but on the UI side rather than on the API. Some of them extend the API entities, but it uses grape for all of this, or grape entity. And when I discovered that, I was quite unhappy because it's so much harder to cache. This merge request actually introduces a way of doing that caching inside of the grape entity rendering. So we'll have a look at it because it's interesting. It does require artisan or handcrafted JSON in the controller. You actually have to stick it in as a string. It's in as a here doc, because you have to take pre-generated JSON from this pipeline. That's going to be really awkward looking at it as a replacement. Let's do side by side. So you're looking at this where it was before. It was just render JSON. With this, this returns basically just a really big hash, and then Rails converts it to JSON. Not super fast. What we needed to do is to cache the JSON representation of each of those individual pipelines, because each pipeline can change its status over time. Obviously, as it's running, its status will update. Luckily, the pipeline records do actually get updated, they get touched. So an easy way of expiring cache keys on Rails models, which I totally forgot to put in the slides, is you call dot touch, or the instant method touch, on a active record thing, and it updated it, and it doesn't call any callbacks. There's even a really nice touch all, which you can call on a collection, and it will just do all of them in one query. Very useful. And actually, the pipelines do already do that. So their cache keys are going to change as they are, as they change, as their state changes as they go through it. But the trick, like if this was just HTML, this would have actually been quite easy. I'd already have merged it. But what we need to do is to modify how the serialized stuff works. So in that regard, I built a caching serializer. It's pretty horrible. And what it does, the problem is that it can't return a hash like the grape normally does. What grape's returning, the grape entity representation thing, returns a Ruby hash, which then gets converted to a string. But we don't want to be serializing a hash into the cache and then back out again. And I did try it, but it said that it wouldn't let me because I had to write a specific way of serializing, deserializing it. It's much more effective, as I was saying in the previous talk, to cache the view. So cache the finished JSON. So JSON rendering is quite slow, and it generates huge strings in Ruby memory all the time. You just want to avoid it. So in this regard, I added this, but what it does is it returns a string, just a big string rather than a hash. So it does function slightly differently. And what it uses is the fetch multi method, but it's a modified one that I've added in this merge request, because the Rails one by default doesn't work the same as fetch. So Rails fetch, when you do fetch your key, do, and then you give it a parameter to the prop, which would be the object that was missing, the key, basically the object that's missing from cache. So you like give it a user, it passes that user to the missing block or whatever. Or it doesn't, or you don't need to because it's only a single cache call. So in that regard, you don't do that. But on the fetch multi one, it just gives you the key, which isn't very useful, because what can you do with your weird combination cache key when you've got a missing record? And you're using it for essentially a loop. You're using it for multiple records. So you can't just take the instance variable of like user that was just defined outside that block. You need it passed to the block. So I've added a new method in this which is our own version of fetch multi, and it actually provides you the object. So my cat has started snoring as well, so I apologize if you can hear that. It's not me farting, it is actually the cat. So that's quite useful. That I might remove that from this and actually merge it into the thing anyway. I can talk a little bit about this. Sean McGivern's much better to talk about the Redis cluster validator. It's kind of preparing us to run Redis as a cluster, kind of like the Memcached cluster setup I mentioned. You don't have to worry too much about it, but it's kind of tied to how certain requests might need to be all on the same cache server. I think there's some documentation on it. I'll try and link it up in the issue, but just for simplicity, we'll ignore that for the moment. It's something that will crop up in reviews if it's needed. And I just send all of my caching merge request reviews to Sean McGivern, and he tells me when I need to put that in. So what this does is basically for each of the things that are passed to the caching serializer, in this case, the pipeline, it looks to see if it's got a rendered JSON version of that entity in the cache. And if it doesn't, it then does JSON.dump and does that. It works for both one record, it's fairly boring bit of code that, but or returns all of them. And let's see if I can load this up locally. because it's kind of interesting. I've never managed to get the pipelines working very effectively on my local machine. There we go. What was that branch actually called? So this merge request is sort of almost there, but because it does some slightly odd things, it just needs a bit more going over, really, to get it in a nice place. Oh, that's not what I wanted to do. Just wait for the GDK to restart.
Could I ask a quick question? I'm sorry if you covered this in the minute before I joined. So, is all of our cache backed by Redis, or you mentioned Memcached? Do we use that as well?
No, so we use Redis entirely at GitLab, and I did actually ask. I asked Andrew Newdigate why, just because I was curious, and it is basically because it's one less moving part, and that's a very understandable reason to choose it. I don't think there's no problem with Redis. The thing with Redis for me is that if I was running my own service, I wouldn't use it. I wouldn't run it. It's like I don't like running my own Postgres database because I don't trust myself to set it up right. And Redis is very similar to it in that regard. I don't trust myself to set up a Redis cluster and have it not fall over. But Memcached is so easy to set up to be largely infallible that I'd kind of do that. But yeah, in our regard, the reasoning behind it is kind of, we already use Redis and it's one less moving part, and it's simpler for customers on self-installs as well. They only really have to worry about Redis. We run multiple Redis clusters. I think we have 3. We've got one for like background jobs, particularly. We've got one for the cache, and then we've got another one that I always forget the name of. But for a lot of installs, they're probably just using one. And it does kind of make it easier in that regard. It's kind of funny, I think, when you use a cloud platform, that even if you use a Memcached offering, it's probably actually Redis. Underneath, it's quite... and one of the reasons for that was originally Memcached didn't support stuff like authentication of any sort, really, for a while. But I think it does. I think it supports SAML now. Yeah, did that answer that question? Cool. Let's have a look at. That's the wrong project. You can see what a mess I've made of my own GitLab install. Right. So merge request pipeline thingy. It's a shame I can't really share too. So I can share my whole desktop, but it's massive, so it ends up so small that no one can really see it. So what I'll probably do is show you the effect in the browser, and then we'll look at the stuff afterwards. So this one's got 5 pipelines. Let's get the network panel back up. Right, pipelines. So first pipeline load on this is 3.4 seconds. So that was totally uncached. And there are 5 items here to cache. So if we force refresh now, it should be less. What did that come in as? So that's under 700 milliseconds now. So those are being served from the cache, and we can look at that in the cache as well. And when you change the state of these, I would click it, but it doesn't actually work on my machine anyway because I never set them up properly. So it'll just return the same status, I think. We can try it and see what happens. I don't know what that did. So in theory, what would happen now is because I've it's a multi-fetch cache. If that one had changed, that one would have expired, but the other 4 are being served from the cache still. So there's 2 ways of caching it. Like we use the HTTP caching on this pipelines endpoint as well. When it's polling, you can see it polling here, 75 milliseconds, and it's you'll see in the I don't know if it's showing the response headers. There you go. So you can see it says no cache, but it's also got an E tag there. So X GitLab from cache. I'm assuming this is actually being served through Workhorse or something. And you can see it polling there repeatedly over and over. And so that's just returning the browser cache. Is instructing it to return the cache. But when that changes, so that E tag will probably change with the latest pipeline, that whole cache is gone. So all of the pipelines have to be re-rendered. What we've added here with the multi-fragment caching is that 4 of those pipelines now don't ever have to be re-rendered. They're totally broken. Like they failed 2 months ago, 7 months ago. Those are probably never going to change. They're probably always going to be, I say always, going to be served from the cache. If our cache lasted forever, they'd always be served from the cache. And for currently in progress merge requests, this is going to be very effective. I mean, it saves, what, 2.5, 3 seconds off a request with only 5 pipelines. With 20 plus, it's going to be pretty huge. So we'll have a look at the logs, because being able to see your the effect you've had in the logs is quite important, I think. And you can see it in the browse logs, which is quite nice. So we'll swap that over. Let's give it a go. That's obviously not the right way of doing it. So this won't show it in the logs because this is a custom one and it doesn't use the standard Rails template stuff. I will add logging to it because that would be quite nice. Let's go back to the actual code for it briefly. And see if there's anything else of interest inside it. So this would be able to be reused elsewhere. A couple of things I've added when doing other things. The big problem with grape entities in particular is that you can't cache parts of them. Well, you can, but you can end up with an awful lot of cache calls, especially if you're rendering multiple entities. And every entity has 5 caches in it, whereas I've rendering 100 entities, you've got 500 cache calls. It's very frustrating. You want to render cache the whole thing. I've got another merge request that sort of relooks at how we can actually add some extra cache context into the actual. My operating system just pops up saying, "Do you want to upgrade your Ubuntu?" Yes, this is the time I want to do it at. All right, let's see if I can find this. So something else I've been looking at adding, which I think would be useful, is to add some way of defining additional caching context on the grape entities, because they are such a problem. And because what you can do is, by default, the cache helpers I've added to do it will take the object that you've given it that you're going to render in a grape entity. So we've got a grape entity for a branch in this case. So it takes the branch and it looks for branch cache key as a method and tries to use that to find a cache entry. But we probably need extra stuff in it, and branches are a great example, because sometimes ideally what you'd use is that touch mechanism I was talking about before for child relationships in Active Record. You want them to, when they're updated, you say on any of the belongs to associations. So say a branch has like a child branch model and its parent is a branch. And on that belongs to parent branch, you'd have to do touch true. And anytime that child branch model is updated, it would update the updated app of its parent. And that would mean that the parent's caches would also expire. Very nice. That's what Rails wants you to do. That's the Basecamp way of caching. That's what they want you to do. And it's very effective if you did it from the start. But if you're coming in later and you need to figure out how every single model can affect each other in different ways. A branch is a great example of this. Protected branch has no relationship to a branch because branches aren't really in the database, they're in Gitly. So they're not active record objects. They don't belong to a protected branch or anything like that. So the protected branch is quite important as well. You need to know that on the API when a protected branch changes. And in fact, in this entity, you can see it's exposed protected, and it's whether it's protected, whether developers can push, whether you can merge, that sort of thing. This is quite important. It's also got current user in there, which that's always a red flag. Anytime I see the word current user in something I'm trying to cache, it's like, oh. And then you have to go off and you have to find out why it's current user. Because sometimes it doesn't matter that it's the current user. Sometimes, in this case, we're just checking if the user can push to branch. So what if I just take this check and I move it up here into this cache context method, and we call this as part of the cache key for rendering the pipeline entity. So we'll take the branch cache key and we'll add this extra context from the grape entity file. We'll give it the branch and we'll say, what other context do you need to enter this key so that this record expires correctly, and sort of jam them together. And so in this regard, this will be kind of effective. So instead of having like worrying, oh no, now we need this cache to be user specific. We don't actually care about the user here. It's not like it's showing their name. What it cares about is if they can push to the branch. So we can move that check and just stick it up here. And then it will cache based on whether the user can see the branch. And it doesn't matter who the user is. It only matters what they can do. And that's really useful when it comes to doing these sorts of weird little caches. And so in the pipeline one, that needs a little bit of tweaking. It's got a cache context method here. You can see I'll merge the two together. It'll actually be the other one. But you can see it in here. So the cache context for pipelines. This is the most boring part of adding caching, is you just have to do it at this point at GitLab in particular. Everything that might appear inside that cache section of code, you've got to go through all of it. You've got to go through the view, look at every helper it calls, go into the helpers, look at every other helper they call, look in the enterprise edition. You've got to look all the way down through the stack of what might appear, because there are current user calls everywhere. They're never passed in as method arguments as well. It's where there's a bit of a flaw in how Rails works. When you've got helpers in particular, they have access to the other helpers without being passed those values. And so it's very hard to tell where those things are dependent upon. So for this one, in this instance, I spent about a day going through everything that might appear in those pipeline things and finding all of the requests that are tied to user specific stuff. And some of them are kind of interesting, like whether the user has permission to view and rerun builds and stuff like that. And there was actually a huge list of those, but I think you can cover it just by doing this permission check. So covering multiple permission checks with one of them. Might need to check that, but it seems to work. It seems to be very effective, and it seems to work quite well in that regard.
So a question along those lines, how do we prevent people from not being aware of this constraint and then adding new current user checks down somewhere in the stack and not knowing to update this? Is there some sort of fail-safe spec? Yeah,
it's quite difficult, really. And that is an argument.
Seems
especially
pretty much guaranteed to happen.
Yeah, I agree. And that's actually one of the reasons why it's not great in this. Having it in the pipeline serializer, I think, is a little bit, it can be a little bit weird. Having it in the entity files, I think, make quite a lot of sense on the API side, because the API entities don't typically call out to lots of helpers. But yeah, in terms of views and helpers and stuff, it's just a bit of a pain. It would be nice to automate it a bit. I'm really rubbish at writing Rubocop things. And I think I've written one, and it was a copy and paste job from somebody else's one. And their one was still better. So I don't generally write them, but it would make a lot of sense really to actually look for cache calls in the code base and then helpers that might be called inside of them. What I would do, and I've done it in a couple of places, is to add comments in related sections. We've got header comments in some files that say, there's one on the commit view, for example, which is if you modify this, you have to modify this Vue.js file as well, because they must remain, they must keep parity. And we can kind of do something similar. So if you have added a very important cache, say, for example, on pipelines, go into the pipeline serializers and mark them and say, these are used in a caching context. Equally, I suppose in this regard, because the pipeline serializer descends from caching serializer, we might be able to pick that up in Rubocop and just flag up things that are modified in there, potentially look for current user, like new calls, stuff like that. We might have a chance of that. But yeah, it's something you kind of do just have to remember to a certain degree. I wish it was simpler than that.
Yeah, I mean, statically detecting that seems pretty tricky in a generalized way, but I do wonder if dynamically detecting it might be an option, because we do have a block that can, like a caching block that wraps whatever call we're making. So if we can set a global flag in there and then hook into current user and intercept those calls and just bail out during development, if we detect something like that.
That'd be an interesting trick.
Aspect-oriented programming.
I added a comment in the chat to the effect that, at least for the policy checks, that should be fairly straightforward.
Yeah, I think if anyone is good at Rubocop and wishes to write rules on this, I would be more than happy to defer to you, because I'm truly rubbish at it.
I don't think it's possible with Rubocop. I don't think a static check is possible.
Yeah.
But if we have a delimited block that we can run things in, straightforward to do it dynamically.
Yeah, I think that makes a lot of sense. And one aspect that would play well today is that I've started adding our own cache wrappers. I found this when I replaced the JSON interpreter that we use in GitLab, that for things where we might change dependencies or things like that, it's very useful to have our own system, like made in-house bit that just wraps these things. So we now have a GitLab cache class. We can take that and kind of mirror all of the Rails methods, just defer to them, but then wrap them in our own things, add our own metrics into it if needed. We've got a place to put that now, which could work quite well.
And it theoretically should be possible to write tests. Like you could do the dynamic check for current user, but there could be other variables that impact what you're caching. So you could have a test that is like, render this with caching and then render it differently and try to compare it somehow.
Testing and caching is one of the things that I didn't stick in the slides. And I have a bit of a guilty reason for that, in that I never do it personally. I don't think that's right at GitLab. I do write tests for caching at GitLab. You'll all be pleased to know. But it's where feature specs in particular come in for me, is that they're very effective at testing caching, because you really should be hitting things ideally with multiple users. That's where the big check is for a cache. If it's a cache where you're worried about user data, like actually worried, showing slightly incorrect pipeline status or something is different to showing someone's home address or something like that. This is obviously more of a problem. And for those things, you can add essentially like a smoke test that runs the same thing as two different users and tries to see if it returns different data, as it should do. And the caching is enabled in the test suite. There is something you can add to, I'm going to swap the screen share back over. We've got some helpers for this. We've got some of these useful helpers. So when you're doing a cache, the Rails clean Rails memory store stuff, I don't think it's actually that useful. I'm assuming it is for certain things, but it won't work across request because it just stores it in memory for the request. The really useful one, if you're doing feature specs and you want to test a cache over multiple page loads, you'll need to use this. I suspect, I'm not entirely certain feature specs, but you want to add the flag use clean Rails Redis caching, and it will clear the cache beforehand and then use it for the course of that test. And you can hit it multiple times and it will actually cache between requests. That is very useful. And I totally forgot to stick it in the slide deck, which is a mistake. But any other questions or points on that?
And when you have these multiple levels of caching, is it possible to have race conditions? For example, like something in the UI triggers an API call which would update the updated at, but that isn't propagated in time for another level of caching to catch it, or something along those lines?
Yeah, it's kind of interesting because the touch calls are very fast, and I'm very happy that I discovered touch all, which is extremely useful, which is a great for mass expiry of something. They are very fast. You could potentially get slightly delayed responses still.
This seems especially like if it's another system, for example, Gitly, but something Gitly does, which is a distributed call, somehow as part of your cached key, but that's not within your database transaction in the context of the Rails request, something along those lines.
Yeah, it's kind of interesting because I mean, the bigger risk that I've found, especially when you're using timestamps, is you can accidentally introduce infinite loops quite easily, where one thing updates one thing and then the other thing updates the other thing. And the one general good sort of point there is to always expire upwards. So instead of expiring child relationships, so I've updated a namespace. Well, now I'm going to expire the caches of all groups and all projects in that namespace. You kind of want to go the other way. You want the project to be expiring the caches of the namespace and only going up, because otherwise, when you add the touch commands lower down, so you add a touch from project back to namespace, and then you expire all the projects when you update the namespace, it just sticks in an infinite loop. Thankfully, that one does show up in test suites at least. But yeah, with other things, especially tying things into cache, you can get sort of race conditions in particular. It's why the Rails fetch command is particularly useful, because we've actually had I think Nick found a couple of race conditions in one of our things. I've even written them in. If you're doing a read and then a write, especially if you're directly using the Redis adapter, I can even bring up an example of this because I wrote it and I wrote a race condition directly into it. So where is it? It's quite hard to read through this. Yeah, so here is a sort of a race condition where you're reading from Redis and then you're checking the values and then you're writing back the missing ones. That's got a gap in it where those values can change from elsewhere. Ideally, you don't want to do that. There are Redis ways around it. The reason why it doesn't matter in this case is just because of the way that specific cache is built very weirdly. It's like an additive cache where the cache is updated with extra values, and it's even if it's slightly delayed, it doesn't matter because it's still mostly cached. It's a really weird integration. But essentially what you kind of want to do is use the built-in tools where possible. So that the Rails tools where they fetch, they're doing the read and the write in like one command after another. I think they're pipelined. Is it pipelined or I don't know if it's got an example in here. There's two slightly conflicting things with Redis. So you've got pipelined and you've got like a transaction one. and they're slightly different. One of them just sends multiple commands over the same connection, and the other one actually like sends them like as an ordered requirement in the transaction, where you do one then the next one. And I can't remember what the different term for that one is. Don't know if anyone else knows it off the top of their head.
It's multi.
That's it. Nice. Yeah. And so those two are kind of different. They're worth sort of keeping a note of, I guess. In this regard, we're using pipelined here, which is the wrong one, in that just is more efficient. It doesn't actually have that that race condition sort of thing involved. But the default built-in helpers, so if you're using the Rails cache fetch stuff, does actually keep that in mind, and it's quite effective. Anything else from anyone? Otherwise, I'll find another intro. Anyone want to see the avatar cache? Because this one was fun. So this uses a Redis hash specifically because of the way. Has anyone used the network controller endpoint, the page, since they've been at GitLab ever? It's the one that shows you like a commit graph. Let's bring it up. It's really, really nicely built. It's got a really lovely sort of interface, and I didn't even know it existed. It's this one, if you click graph, and it renders this thing, and it takes a while, particularly on GitLab. It is not the fastest. I think it might even time out. It definitely timed out before though, and the reason why was that for each item that it renders on this, it's got the avatar next to it. But because of the way it renders the page, our avatar helpers have two ways of finding an avatar for a person, because not everybody is a GitLab user. Some of them are just email addresses, but we still try and look up their avatar. And it works by either you pass it a user, and it uses the user's avatar, and we've probably already loaded the user because we're passing it in, or you give it an email address. And the first thing it does is to try and find a user with that email address. And this page did that for every single commit, which you can see it is timing out, trying to render. I'll do it on a small project, just as an example. Where's one of mine? There you go. So it renders this avatar, and it wouldn't even cache it between users. So for the same user, it would, like, what's that, 30 commits, it would make 30 queries, but those would be cached by Rails, but it was always looking them up. So I added a very, very specific cache around this endpoint. And it's the biggest performance increase I've made at GitLab that no one has noticed, because no one ever looks at this page from what I can tell. It's got like a request per second of 1, I think. It's just, it might not even be that. It's, we can actually have a look. It's quite a shame, because it's actually quite a nice feature, but I've bookmarked the useful dashboards, or the ones that I find most useful. That's the wrong one. I'll show you a second in the Redis one what I look for when I'm adding a new cache and I don't want to upset the SREs by killing Redis on a Saturday when I was enabling feature flags, as Igor probably remembers. Here we go. So yes, under 1 ops, under 1 request per second. No one really goes on this endpoint, but the difference I made to it was so massive. I felt very excited about it. It actually is a cache that gets used elsewhere across the site, but because they're just speckled in amongst everything else, you don't really notice it. And yeah, the way it works is it's basically a hash in Redis, and Redis hashes are kind of weird. It's not like a Rails hash. It's only 1 level deep for a start. I don't think you can have nested ones, as far as I know. Might be able to. but what it allows you to do is have a second set of level of keys and extra values on them. And that's really nice if you want to expire a lot of things in one go, because you just issue a single request for one cache key you know about, and then it deletes all the ones you don't know about, but are definitely related. And so in this regard, we know the user's email address. And when that user happens to sign up or they update their avatar, we just unlink all of the avatars by just looking at for their email addresses. We just send the email addresses as the keys and delete them. And in this regard, it's very effective, the way it works. And it cut out loads of these queries, but this will never get used for anything else. It's not like a universally useful piece of work, unfortunately. Looking at the Grafana stuff for like what you do when you are breaking stuff, and you, as I said earlier, you have to test in production. It just doesn't work locally. I can show the pipeline one locally. That's very obvious. But when you're adding a really tricky cache, like something that's going to be kind of intangible, like we're trying to add one around checking the binariness of a file, and we look at it locally and it totally works, and you stick it live and you find out that people don't visit the page often enough for that cache to be useful. That's just something that happens. It's a pain. You just have to revisit it later. With feature flags, it's quite nice because you can just turn them off and come back to it. Although I have quite a lot of open feature flag issues right now, and I feel quite bad about it. So there is a dashboard for the Redis cache. It's got very exciting wiggly lines. I largely don't use a lot of the ones at the top. The ones I look at quite a lot are further down. Where is it? Right. So memory saturation is probably not going to change. It probably stays quite constant. Memory used rate of change is quite interesting. But the really interesting ones are down here. So expired keys, if you're seeing a lot of expired keys, that probably means that a lot of new stuff has just come in, or we've issued a really big explicit delete. It's quite spiky, which kind of, to my mind, means that it shows a lot of explicit deletes. If it was just Redis expiring them of its own accord, I'd expect it to be kind of smoother. No, it probably ties quite related to, ties in quite specifically to traffic. The more traffic you have, the more cache rotation you're going to get. So key rate of change is quite interesting in that regard. The one that I found very useful is looking at replication offset. If you're adding new cache data, and you're adding quite big cache data, so what was one I added recently? I was adding some caching around commit partials, and they're rendered everywhere and under quite a lot of traffic. Well, suddenly you're adding many megs of data very quickly. It will actually, you'll see it pop in there as the Redis servers are lag slightly as they're trying to replicate an increase of data coming in. You can kind of see that. It's kind of useful to know. It's just something to keep an eye on, because if you cause a really big spike like that, it might, if it's just a spike, it's probably bad. If it stays high, it probably means that you're just generating an awful lot of cache data and maybe not just getting the reads, maybe it's just churning a lot. I'll see if I can find some other examples of that. Let's have a look at, has anyone got any other suggestions of places to look, by the way? Otherwise, I'll just keep going through other things of interest, really. Are people generally interested in the API caching side of it? Do you want to look at that? Or more of the Rails side of it? I don't know what's of more relevance or interest to people, really. Right, in that case, I'll just go with whatever I find first. Let's have a look at. You can see where I messed up a cache key. That happens quite easily. Let's have a look at. It was kind of interesting. So I've got, when I put benchmarks in a caching merge request, they are the least scientific benchmarks imaginable, in that I sit there and I refresh the page a few times without the cache, like 10 times. And then I sort of just pick the most average looking number. And then I do it with the feature flag enabled, and then pick the best looking number, like the very lowest, and I'll stick those in an issue. But generally, it's actually quite a good approximation. It's not going to be quite accurate compared to where you get in production, but not necessarily in the way you think. Your dev machine is probably faster than some of the cloud servers. Yeah, I don't know what the specs of our cloud servers are at the moment, but it does vary by machine. I've noticed that, for example, our CI servers are slower running the test than my home personal machine is. That does affect your render speed. It's just, especially if you've got lots of CPU heavy stuff. So in this regard, this was a fairly good example of caching a partial. Let's just look at the file rather than. So this is a good example of using this cache if thing. It's kind of nice. So up here, I've just got a little check to see about feature flag, and then cache if the cache is enabled. If it's not, it just returns the contents as normal. It doesn't really add any overhead. You just pass it as the first option. Yeah, with the contents, this is just on the when you go to like a project homepage bit. So like you go here, I've cached sections of this, and it's kind of all a bit different. So there's lots of different keys. And this is where that gem I wrote comes in useful, because you can do all of that and only use one network request, but you still got to look up all the keys. So you just got to keep that in mind. And so in this regard, I've cached, what we got? We got the tag list, which isn't the repository tag list, it's like the fancy words tag list. And that can be cached pretty reliably. And I've just put a vaguely long TTL on it. I tend to put expires in on a lot of caches, and it's kind of a guessing game as to whether the time will be effective. But then there's the buttons as to whether a user follows that project, or whatever we call it, starred the project or forked the project. And those have to be cached kind of per user, because they're very use specific, like notifications and stuff like that. But it's a small value, so it's not too problematic. The download links were kind of expensive, so I added those to cache. And the most interesting one was tied to, where is it? The stats. Yeah, that was it. Which, yeah, these stats are kind of complicated in how they're calculated, but there's no need for those to be fresh every page load. They're, you know, it takes up to about a minute to process an incoming push, just from the various hooks going off, all the authorization and stuff. So showing that slightly delayed doesn't really matter, and it actually does stop a fairly expensive bit of code. It's actually got a few queries in that. Let's find some other stuff to look at. So there was one recently for a performance request that was quite urgent. A regression meant that for a big potential client, this was going to flag in their performance review. And this is a good example of using caching as a hack. And this rather unfortunately doesn't seem to have as big an effect in production as it does in the performance tests. It's like a performance test defeation tool. It's very effective, and this is that thing that I've added called cache action to the API, which allows you to cache an action for a certain amount of time. And basically, you give it a short TTL, like 30 seconds or whatever, and this endpoint was the branches list API, and it's fairly problematic in that it hits Gitly every single time and returns every single branch in a repository, which is very unfortunate because there's many tens of thousands on GitLab, and they all get loaded from disk for every page load, which was not super great. We actually have a proper fix for this, but we had to turn it off because we need to make some changes to Gitly to get it properly fixed. And so in the meantime, this is actually almost a security fix in that endpoint will only return fresh data every 30 seconds. So 30 seconds of Gitly requests will be sort of ignored when someone pushes a branch, and then you immediately go and check the API. Chances are, from looking at the traffic data, most people aren't polling the branches API that fast anyway. They're polling it more like once every 5 minutes. And so the chance of them ever even seeing that cache data is very low, but it's actually very effective in stopping that Gitly load. And the thing that in production, I watched the charts, nothing. Made no difference whatsoever that I could see. Performance tests, A*, totally solved the problem. No issues whatsoever in future, sort of, it just dropped. I think it shaved seconds off of the response because it stopped all the Gitly load. And so it's actually more effective on weaker hardware as well, actually, because it stops so many disk reads. One thing I mentioned on the first call was about disk caching versus memory caching. And it's something we don't do at GitLab yet, but it'd be interesting to explore for things like rendered blobs, for example, where we're rendering just big bits of markdown. The problem we've got there is that there's a lot of user-specific stuff in that I never realized. There's all the redaction stuff tied into whether a user can see specific links, whether we should show markdown links to things they can't see. And what we're going to do about that is to actually move that redaction step further down the stack so that it happens just before the view is rendered. And that will mean that we could potentially cache these big blobs. But sticking them in Redis feels slightly wrong. I mean, to put like 2 meg of HTML for every markdown file, like every variation or commit of it, seems quite heavy. And the problem we have is because you're putting big things in it, it'll work, but your cache will rotate faster, and so it'll be less effective in other places because you'll start losing other caches that might be important just more often, and it could be a bit of a problem. But caching that to disk makes tons of sense. How you do that in a cloud environment, that's where it gets a bit more tricky. You could, and I do it, I've cached directly to application servers, hard disks. You just keep in mind that when users come back to a different server, they're not going to have that cache, but you can get tricks around that, like sticky sessions on the load balancer to always send them back to the same server. Doesn't work. Doesn't really work. Or you just assume that sometimes they're going to get stale caches, like that's how it happens. You could do something really horrifying and actually synchronize the cache between the different disks. Probably don't do that. The way it could work for us might be an object store, like storing it in S3 or something like that. That would be quite an effective use. You could use it like a cache. Maybe even just using it, like loading it and using Cloudflare as a reverse proxy cache, stuff like that. There's sort of options that we could have, and then actually redacting it afterwards and doing the user specific stuff on the finished product could be quite an effective use of that sort of data. But that's where it gets quite interesting. It's worth having a look at mixi.jp, that Japanese, I say it's worth having a look. It depends on how much Japanese you read, I guess. but it's a Japanese social network, and they solve problems slightly differently to a lot of the other ones. But it was around the same sort of time as things like Memcached existed, but it actually has the same protocol set up, but writes to disk. And it's really weird how fast it is, considering that at the time as well, when it was released, it was reading off of spinning hard disks, and it was way faster than it has any right to be. It's kind of an interesting piece of software, and quite fun. But that is something that we can look at a bit more as well. Any questions or points? We've got about 25 minutes left of the scheduled time. Let's see if I can find some other interesting measures. I am just going through my own just because I know what I did. But other people have been doing some really nice stuff. This is that storage banner stuff I mentioned earlier. So you can see where the changes came in on this. If anyone wants links to these as well, I'm happy to provide links in the issue if there's anything you want to look through. Especially around sort of how the testing is done can be kind of useful in looking at those sort of things. What else have we got? Not specifically tied directly to caching, but looking more at sort of view performance. I've mentioned a lot in the first talk about why views are slow, but sort of knowing why they're slow can be quite important when you're coming to caching. And this is one where I refactored a view just to make it faster. You can see my choice benchmark selection as well. They're not massively faster, but saving 100 milliseconds, whatever, adds up over time. And in this regard, this was one of those ones where I removed partials. So this partial would have rendered really fast because it's just tags. There's nothing happening in that. That's in any of the templating languages for Ruby, it's almost nothing. It's because it does something where it sort of creates like it tokenizes all of the tags, and they're all sort of like symbolized or something. They're very neat, very fast. They often all use the same backend. There's something called Temple as a gem. Interesting thing, worth a look. But in that regard, that partial, this isn't very big. That was 10% slower than if that is just in the view, roughly. And yeah, it's not slow, but it's 10% you could save by just moving 12 lines into another file. So actually having slightly bigger templates, I mean, yeah, it can make maintainability be awkward. Partials are very good when you're sharing data between multiple places because you don't want to be duplicating your template. But if you're only using it in one place, totally makes sense to have it in it just in that one place. So I removed a couple here and I just shoved them into the view. And that's all this merge request is. And that's 100 milliseconds better. Yeah, roughly, just from doing that. And that ties into the caching side of things, because once you've got some of this, now that these are in one view as well, if I put a cache around this, the template tree digest will update correctly. Whereas, whereas if it's inside these partials and I put a cache around this out here, it would, and I updated these templates, it wouldn't update the cache because they wouldn't have the template tree digest bit. I think there's a bit of a trick around this. The reason why it's so much faster here is because these weren't being rendered using the partial collection rendering thing. So this is being rendered multiple times. Is there a loop around it somewhere? I think this might be being rendered. Oh yeah, so the expensive one here was this being where it's rendering this render here, that doing individual partial render calls inside a loop is really expensive. Doing the render call where you pass it a collection and then you say like the collection, that's much faster. And that then is only about like 10% slower than not using the partial. But rendering it like this, where you pass, where you make multiple render calls inside a loop, is just super slow by comparison. I put a thing in the slides. I'll put it in the chat as well. It's where was it? This article from Scout is very good. I'll stick it in the chat. It's very interesting, and they actually go through the different reasons for this. Well, they don't necessarily talk about why, and no one really talks about why. I think why is because of the template path lookup in Rails. I think that the way it actually takes the partial name and finds the correct partial for it is where that overhead comes from. I don't think there's any real way around it. But using that collection render is much faster in that regard, because it only performs that partial lookup once, whereas when you're doing it inside a loop, it does it every time. Where it gets interesting then as well is when you're using that collection renderer, you can then use that cached true option, and you can cache multiple items. I haven't managed to use that at GitLab yet, but I might be able to show an example from my own stuff, just because it's kind of, I've shown like custom versions of it, but let's just have a quick look and see if I can find it. Oh, I made my own project so complicated. It uses multiple other things now. No, I don't have a good example of that, unfortunately. But yeah, doing that collection stuff, that's a very, very good performance boost in general. It does make a lot of sense, and it's quite effective. All right, what else have we got? Trying to remember what other ones. Yeah, it wouldn't surprise me. It's kind of weird. It's always a compromise when you're looking at the partials, between maintainability of like 1,000-line view template and the performance overhead. On my own stuff, I don't really even question it, but I also have quite small views anyway. It's obviously more complicated when you've got such a complicated application like GitLab. One area where I noticed it being a problem in the past was in the navigation rendering, but that's been taken over by frontend. That's some of these areas where we render lots of these mini partials, or like rendering the same, like if you look at a diff at the moment and you're hovering over lines and it renders the comment button and stuff, there's one of those buttons on every single line. There's like 100 of them rendered per page. Moving that to JavaScript makes total sense. That's a very good use of JavaScript by just rendering something once and reusing it. That's effectively a form of caching. And it's the same with these sort of partial renders as well. Let's see, what else have I got?
I wonder if it's that drastic. Like, should we consider like if a partial is really only used, if it's not reused code, then just discourage using a partial at all and accept that a more complex view is more performant?
Yeah, I mean, I think it makes a lot of sense. The one to look out for, I guess, is the one where you're rendering a partial inside a loop. So if you're not using the collection render and you're rendering in a loop, that's a red flag. That's the biggest performance problem with it. Using like one partial somewhere, it takes 5 milliseconds to render. It takes 6 milliseconds if it's partial and not in line. It's not the end of the world. But yeah, the one in the loops is where it becomes very much a problem quite quickly, and especially when we have pages where we render like I think until recently on commits and stuff, we were like unpaginated and rendering hundreds of diffs on a page, and each the diffs is actually quite a problem with it. Diffs renders I've got multiple merge requests for this, renders the lines in a diff. Each line is a partial render, but it does use the collection API, so it's not as bad. We'd gain maybe like 10%. I do have some stuff around that. One of the sort of side effects of caching, in fact, is that you reduce memory usage quite heavily, because what you're largely doing is getting one big string from somewhere and then you're sticking it in the view. Where it's really effective is cutting down on all the little string generation that you're doing until you get to the final generated string for the view. So when you're rendering a template in Rails, and you've got some stuff from like a model, whatever, and you're outputting into the view, or it sticks it out as a string, all this sort of stuff. And when you start joining it together in the views or doing things like that, it starts to get quite expensive, and you're generating a lot of strings, especially in loops. And the ultimate goal of the application is to generate a big string and then stick it out to the browser. So the fewer lumps of strings you stick together by the end, kind of works. There's a really cool thing someone put me onto about Phoenix, the Elixir framework, which cuts out a rather major part of that. And I've had a look at doing it in Ruby. It's quite hard, but it doesn't concatenate everything to a big string at the end. It just outputs it all from its memory in an array, and just like writes an array to the response socket and doesn't ever concatenate it into a big string. And that's really good, actually. That's very memory effective. You're not generating these big short-lived things. This is an example merge request where it's just reducing string duplication. And this doesn't tie necessarily into caching, but it's something that caching does help with. When you're doing less of this processing work, you generate fewer objects. And you'll see this in a lot of the benchmark things that I say benchmarks. I don't even think they qualify, to be honest. That I put in the merge request things. Let's see if, what was that one? That's not that one. You'll actually see like the allocations go down quite heavily. That's really useful. Just there you go. So uncached, just rendering the merge request title is 56 milliseconds, and it allocates 65,000 objects. But then you cache it, and it's really fast. It's nice, 2.1 milliseconds, but it's only generating 1,454 objects. That's quite exciting, because that's 64,000-ish free object space in memory to not fill up with stuff. And it's just like chipping away a very big task. We allocate so much memory all the time. Every page request is hundreds of thousands of objects, probably. It's just absolute millions. So much being generated and then garbage collected. But the fewer that you generate, the faster the Ruby processes in general will run. So caching has like an additional effect other than just being faster. It gives the Ruby code more sort of overhead or less overhead. Gives it more space to work in, and it does improve it in that regard. When I've built my own applications from scratch and built them to be fast from the start, even when they get big, I've never had memory issues on them. I could always run them inside the cheapest Heroku setup, the free one, because I don't want to pay money. And you could always make that work. Anytime you go away from that, and in my previous jobs where suddenly we had to add a load of more features because they're just needed by the investors, I'm sure loads of you know what that's like. And you don't get the time to concentrate on that. That's when you notice the performance start to dip, and you notice the memory usage, particularly in your Rails app, just go up, and it never comes down, and you start getting memory leaks. and you implement the ultimate solution, which is Puma Worker Killer, and then it's solved forever and no one has to worry about it. But that happens pretty much all the time. I've never had to install it on my own projects because my own projects do so much caching. Even if they do have a memory leak, I've never even seen it. They really do sit very low. But it also ties in a little bit. The memory usage side comes into what you're showing. You know, GitLab is such a complicated application. It's obviously going to use a lot more memory, but you can improve it slightly. And over time, we're sort of improving this in parts. But there is something to keep in mind. It's something I've missed out of the slides, actually. Can't even remember what was actually in this one. Some naughty strings, which I think should be translated. Just realized that there's even more feature flags that I haven't removed from the application yet, which it's the only downside. I went through on a cache binge of a few weeks and I ended up with so many cache key enablement issues that I've now got, you can see them. I'm never going to manage to close all these. Everyone's going to get really cross with me because they're just going to be satted forever. What I tend to do when I stick them live, you don't have to do this. I think it's quite a nice way of doing it though, is to stick the charts in the comments of the feature flag rollout. I think that's kind of nice because you can sort of see the effects and you can see it over time as you're rolling them out. I'm just trying to find one where I've actually done it. No, let's say I'll do it. This one got any? Nope. That was one that was really interesting. Has that got? Not got a picture. I put something up and it makes the endpoint quite a bit worse. And it was kind of interesting to watch in the graphs. I'll see if I can find the graph because it just gets progressively worse. But the problem I had is that when you first look at it, it looks like it's getting better, but it then starts getting worse. Oh, here you go. So looking at this chart, I enabled the flag around here, and you'd expect this is what it looks like when you enable a cache to start with. Your lines will get wigglier. They'll be quite potentially stable before. It's going to spike a bit, and you're going to see a lot of up and down lines because some will be not cached at all, some will be entirely cached. Ideally, what you want to do is to have everything partially cached, so it's very consistent. But you can see that this just kept getting progressively worse, which is not right. That's definitely not how it should work. It got really bad when I turned it up to 100%. And these are very wiggly and they just keep going up. And the problem was that I'd stringified a class, that has a different identifier every time it's made as part of the cache key. And so every time you load the page, it just stuck a new record in the cache. Not effective. And just nice lot of cache churn. So that one wasn't super great. Let's have a look at.
I think we have do we have a dedicated Redis cluster for caching? I think we do.
Yeah, we do. It's quite interesting to look at the different usage pattern of it. But yeah, it is separate. So you don't have to worry too much about killing it. The thing is, if your cache goes down, your application will go down. But normally the cache should be the last thing to go down. We do have quite a lot of people that are a little bit worried about taking down the Redis cluster. I'm not worried about it, to be honest. It's got quite a lot of overhead, and as long as you're turning it on with feature flags and you let the SREs know, and it's very unlikely it's going to immediately die. Like you turn on the feature flag, GitLab is down. I would panic if that happened because it would mean I've done something really bad. I don't even know what that would be. It's very hard to immediately kill the site, especially if you're doing like a gradual like roll out of a feature flag, so like do 10% of actors, 25%, 50%. You should start to see the problem beforehand. Like if you look at the Redis dashboard, the Redis cache dashboard on Grafana, you should start to see it like its SLI levels dip or thing. It does do that regularly anyway, and you can just turn it back off, which can be quite effective.
They're isolated from each other though, right? Like the shared state Redis. So I mean, the worst thing that's going to happen in this case, in the case you mentioned before, where you created something that was just creating tons of different keys with different names, you're just going to close the space, right? You're just going to expire the older keys, and maybe you'll see some downstream impact on other parts of the site because their cache is getting busted more often because the key space is being used up. But I mean, it wouldn't be like...
Yeah, that's very much it. And I mean, the cluster's got a pretty large amount of RAM. I don't actually know what the servers have, because they all have to have identical level of RAM. I think it's 256 gigs, something like that. Which is just, you can buy that off the shelf now. We need more RAM. That's where the disk caches come in very handy. But yeah, that is all that will happen really. Kind of where it's more problematic, rather than the big, if you had big values that were constantly being written over and over again, like hundreds and hundreds of times a second, that's a risk, because you're just probably going to overload the network ports more than anything else. But it can be just as much of a problem with just the sheer amount of traffic going to Redis. Redis is no longer single threaded, I think. It used to be bound to one processor core. It's not anymore, thankfully. So it should be able to handle higher load. But it is something to keep in mind, I guess, yeah. In this regard, I finally found one. This is an example of charts that I see. This is more typical of what I normally see, which is very unexciting. Like, nothing really looks very dramatic there until it starts going down there, and you can just see, and you can see that there's the higher peaks and the lower troughs in it. That's quite typical. You might be, in this regard, they're only on like a 10-minute cache timer. I would expect those to even out if I up that to like an hour, because I think this endpoint's being polled quite a lot. So that would probably be where I would look to improve that cache key. I think there's a reason I've got it set to 10 minutes on this one. The most fun one to see is when you're cutting SQL requests. That chart whenever you get a good cache going and you cut the SQL requests, that just goes straight down. It looks awesome. You think, yeah, look at what I've done. So nice. And the one thing to keep in mind is something the ops guys mentioned before, is that actually Postgres is better at dealing with load than Redis is. Postgres is easier for them to scale. It's easier for them to fail over. It handles higher load already, whereas Redis is hard to. I've set up a Redis cluster. It didn't work. I've set up Postgres as like a primary secondary setup. It sort of worked. I'd say it's slightly easier, but Memcached in that regard is very easy. So that's why I still use it personally. But it's something to sort of keep in mind. Sometimes if we take traffic from Postgres and one-for-one replace it with traffic on Redis, that actually might not be as effective as we like. It might be faster, but we might be putting more, sort of proportionally more load into Redis. Like it's easier for Postgres to deal with that load sometimes. I have got a couple of merge requests like that, and for that, it's kind of a case of gradually rolling them out and seeing what happens. Yeah. Anyone got anything else? Because if not, I think we're on time. If you do have any questions, I mean, I'm always happy to. I'm going to do another one of these workshops, probably at some really horrible time for me at like 4 a.m. so that I can do it for like the Australians and New Zealanders and all that lot. I'll put up recordings of all of them. But if you have any questions, I'm always happy to answer them. Tag me on merge requests, or I did make that issue. Can stick questions in there. There's some people in the company who are very experienced in caching as well, who maybe it's not very obvious who they are, so I'm always happy to sort of link to other people. Although the amount of merge requests I give to Sean McGibbon is going to make him like quite cross with me at some point, I imagine. It's like, it's a caching merge request, I'll give it to Sean McGibbon. But I feel like he probably didn't volunteer for that role. But yeah, I'm always happy to answer any questions. So if there is nothing else, I'll end it. But anything?
Thank you, Robert. This was gripping and fantastic. Very enjoyable. Thank you.
You could tell that I ran out of puns about halfway through the presentation, though. I had so many off the start, and then I kept making new slides, and I can't keep going. I don't have that many. I had to go and look up old movies. I've never even seen Tango and Cash.
Oh man, this had all sorts of challenges. This presentation. Well, at least you got to see Tango and Cash. So.
Yeah. Yeah, I'm always happy to do stuff. If you want any extra details on stuff from the thing, there's bits I've definitely missed out as well. I could talk about it for hours, and have done. But yeah, just give me a shout. I'll stop sharing that.